It's amazing how some ideas seem so futuristic, like they just came out of nowhere. But when you dig a little deeper, you often find these echoes in the past.
Yeah, definitely. Like, it's this weird thing, right? Like, something that sounds cutting edge, you think, oh, wow, nobody's ever thought of that before. And then you look back and you're like, oh, somebody actually had a similar idea like 20 or 30 years ago.
Exactly. That's what we're going to explore today.
Awesome.
This whole idea of AI agents working together, it sounds so modern, but it's got some roots that go way back. So today we're going deep into Google's agent to agent protocol, A2A we'll call it. And we're going to compare it to this fascinating project from the 90s. You might not have even heard of it. General Magic's Telescript.
Yeah, Telescript. Fascinating story there. You actually dug up some great resources for this deep dive.
Yeah.
We've got the Google developers blog post where they announced A2A, and then there's a VentureBeat article that dives into it a bit more.
Mm-hmm.
We've also got the A2A GitHub repository so we can look at the actual code. And then
Yeah.
for Telescript, we've got the Wikipedia entry, which gives a good
Law
overview.
basics, yeah.
And then there are a couple of blog posts that one kind of looks back at Telescript's past and future,
Oh, cool.
and another one that talks about how the term cloud might actually have come from Telescript.
That's really interesting. I'm excited to get into that.
Yeah, me too.
So basically, our mission today is to, go beyond just the technical details
Right.
and really pull out the core ideas. What were they trying to do with both A2A and Telescript? How do they compare? Where do they diverge? And, what does all of this tell us about, the big picture?
Yeah. What does it tell us about how agent technology has evolved and where it might be going? That's what I'm really interested in.
Yeah, that's what we're here for. The insightful nuggets, right? Not just the technical jargon.
Exactly. Insightful nuggets.
So let's start with the new kid on the block, Google's A2A protocol, announced just this year, 2025. What's the big idea behind it?
Yeah, what is it?
Okay, so A2A is basically, it's an open standard protocol. And the main goal here is to allow these AI agents that are built on different platforms, like,
Yeah.
you've got different companies building their own AI agents,
Right.
and they want all these things to be able to talk to each other.
Mm-hmm.
So A2A is like the universal translator for AI agents.
That makes sense, because if you have different AI agents that can't communicate, you're kind of limiting what you can do.
Exactly.
But if they can all understand each other, then you can start building much more complex and interesting applications.
Right. The vision here is you've got all these different agents within an organization. Maybe one's handling customer support.
Right.
Another one's managing the inventory in the warehouse. And they need to work together seamlessly.
Mm.
And A2A is designed to let them do that autonomously. So it's like this, this big step toward automating those business processes.
It's interesting, though, because you usually think of Google as being very much in control of its own ecosystem.
Mm.
But here, they're actually trying to build a community-driven standard.
Right. Yeah, and they've partnered with over 50 companies already. Some really big names, too. Atlassian, Salesforce, even LangChain is in the mix. And one of the VPs at Google Cloud, Rao Surpenny, he emphasized this point. This collaboration is key to making sure that A2A meets those, the security and reliability needs of large enterprises. So they're not just trying to, control the whole thing themselves. They're trying to make this a real industry standard.
Okay, so that's the big picture, but I'm also curious about how A2A works at a technical level. What are the moving parts here?
Okay. So technically speaking, A2A builds on existing internet technologies, which is really smart, I think.
Yeah, smart makes sense.
For communication, they use HTTP.
Good old HTTP.
Yeah. For structuring the messages that the agents exchange,
Mm-hmm.
they use JSON RPC. It's just this simple way for systems to ask each other for information.
Right, request, response.
Exactly. And then for tasks that take longer, like you want to see progress updates,
Sure.
they use server-sent events, SSE for short.
Okay, so rather than waiting for the whole thing to finish, you can actually see how it's going step by step.
Exactly. So it's streaming updates back and forth.
That makes a lot of sense. I mean, especially in a business setting, you want to know what's happening. You don't want to just be in the dark until the very end.
Right. And by using these existing technologies, they're not trying to reinvent the wheel. It makes it so much easier for developers to integrate A2A.
Right. Because everyone's already familiar with HTTP and JSON, so you don't need to learn a whole new set of tools.
Exactly. And they've also built in security from the start.
Which is obviously crucial,
Yeah.
especially for businesses.
Yeah. They've got this secure defaults principle.
Okay.
And the protocol supports standard authentication like OAuth and API keys. So it's designed for enterprise-level security right from the get-go.
So now we kind of have the building blocks. How do these agents actually interact with each other? Like, what's the model for that interaction?
Okay, so they've defined this model that revolves around these two types of agents, a client agent and a remote agent.
Okay.
So the client agent is typically initiated by a user's request, and they frame that request as a task.
Okay.
So you want something done, you create a task for it, and then that task gets sent to a remote agent, which is the one that can actually execute that task. And once that remote agent finishes the job, it produces these artifacts, which are the results,
Yeah.
and sends those back to the client agent.
Okay, so it's almost like a division of labor.
Exactly.
You have the client agent, which is responsible for taking the request and finding the right agent to do the work.
Right.
And then the remote agent actually does the work.
It's like delegation, but for AI.
Yeah, that's a good way to put it.
So you mentioned tasks. Like that seems pretty central to how this all works. What exactly does a task involve?
Yeah, what's in a task?
So a task is basically the fundamental unit of work
Okay.
in the A2A world.
Mm-hmm.
Each task has a unique ID, so you can track it. And the protocol keeps track of the entire life cycle of the task. So, has it been accepted? Is it being processed? Is it waiting for some input? Is it completed? Did it fail? Or was it canceled? So it's a way of managing all this work that's happening between these different agents.
So it's a very structured way to keep track of everything that's going on.
Exactly.
Okay, so we have these tasks, and then you mentioned parts earlier. I'm guessing that's the actual content that's going back and forth.
Right. So the parts are like the content fragments within the messages that the agents exchange.
Okay.
And they can contain all kinds of stuff. They can have text, images, even structured data like JSON.
Oh, wow, so it's not just text-based. They can send images back and forth.
Yeah. It's designed for what they call multimodal communication.
Multimodal, so like different modes of communication.
Yeah.
Not just text.
Exactly. So, it's more than just like sending a text message. You can send, richer content, more complex information. So it's very flexible in that way.
Okay, so that's pretty cool. So we have these basic building blocks of communication. What are some of the key features that A2A brings to the table? Like, what makes it really stand out?
Okay. So one of the really important features is what they call capability discovery.
Capability discovery. Okay.
So agents can publish these things called agent cards.
Agent cards, like business cards for AI agents.
Exactly.
Okay.
And these cards are in JSON format. So they're machine readable.
Right.
And they say what the agent can do. Its skills, the URL where it's located, how you authenticate with it.
Okay.
So it's like a little profile of the agent.
So other agents can basically see what each agent is capable of.
Exactly. So the client agent can search and find the right remote agent for the job. It's like a directory of AI expertise.
That's really smart because it means you don't need to know in advance which agent can do what.
Exactly. It can figure it out dynamically.
Okay. And then there's task management, which we kind of talked about.
Yeah.
But how does that work in practice?
Right. So because communication is structured around these tasks, the protocol itself handles the tracking of the task's progress.
Okay.
So this is really important for long-running tasks. Because agents can exchange these updates. They can say, hey, I'm 20% done, or hey, I need more information, or here's an intermediate result. So everybody stays synchronized.
So you're not just waiting until the end to see if it worked or not. You can actually see how it's progressing.
Exactly. And it's not just about individual agents doing their own thing. They're designed to collaborate.
Ah, collaboration. So how does A2A actually facilitate that?
So they can share the context of the task. So they know what's already been done, partial answers. They can share the artifacts they've produced, and even additional instructions. So they're not just working in silos. They're actually working together.
Okay. And then the last feature I think you mentioned was UX negotiation. What is that all about? That sounds pretty unique.
So this is about making sure that the output is adapted to the user's environment. So the part of the message, it says what type of content it is.
Right.
So it could be text, it could be an image, it could be a web form. So the agents can actually negotiate what format the output should be in and what the user interface capabilities are. So, for example, if the user's on a device with a graphical display, the agent might provide a nice visual response.
Sure.
But if they're on a text-only interface, the agent can adapt and provide just a text-based answer.
That's really smart because it means that the user always gets the best possible experience, regardless of what device they're using.
Exactly. So it's very user-centric in that way.
Okay, so you've been talking about these long-running tasks. seems like A2A has some pretty good support for those.
Yeah, so they can use those server-sent events, remember SSE,
Right.
to stream progress updates and even intermediate results
Hmm.
in real time. And they've got this push notification capability via webhooks.
Okay.
So that means the client application doesn't have to constantly check for updates. It can just get notified when something changes. Right. So it's more efficient.
Exactly. So
Yeah.
this opens up all sorts of possibilities for automating these complex workflows.
Right.
That might take hours or even days, and maybe even involve human intervention at some point. So it's a really powerful feature for those kind of more involved scenarios.
Yeah, and you mentioned earlier that A2A is open source.
Yeah, it's totally open
What's
source.
that mean in practice?
So all the specs, the reference implementations, they're all on GitHub.
Okay.
So anybody can go and look at it, contribute to it, extend it, and they've even got a governance board to oversee how the standard evolves.
So it's a real community effort. It's not just Google dictating how it should be.
Exactly.
So with all this in mind, what do you think Google's ultimate goal is with A2A? What are they hoping to achieve?
Well, I think Google's in a unique position here. They have all this experience with running these massive multi-agent systems internally, like at a scale that most companies can only dream of.
And they've seen firsthand the benefits and the challenges of doing that. So by proposing A2A, they're basically trying to standardize how agents can talk to each other across the entire industry. It's like laying the groundwork for this, future of AI collaboration if everyone's speaking the same language. It just makes everything so much easier.
Right. So it's not about locking everyone into a Google ecosystem.
No.
It's about creating a common foundation that everyone can build on.
Exactly. It's like a rising tide lifts all boats kind of situation.
Okay. So that's a great overview of A2A. Now let's go back in time to the 1990s and take a look at General Magic's Telescript. What was the story there? What were they trying to do?
Okay. So imagine it's the early 90s. The internet is just starting to take off.
Right.
And General Magic, the spin-off from Apple, they had this incredibly ambitious vision. They wanted to create this electronic marketplace on the information superhighway.
The information superhighway. That takes me back.
Yeah, that was the buzzword back then. And they wanted to do this using PDAs, personal digital assistants. Remember those?
Yeah. Vaguely. I mean, they were pretty basic compared to today's smartphones.
Oh, yeah, they were limited.
Yeah.
But that's kind of the point, right? And at the heart of this vision was Telescript.
Okay. So Telescript was their solution to the limitations of those early mobile devices.
Exactly. The idea was you offload the processing
Okay.
from those resource-constrained devices to network servers, which is essentially what we now call the cloud.
Right. So they were already thinking about cloud computing back then, even before the term really existed.
Yeah. They were ahead of their time in many ways. So instead of trying to cram all the computing power into these tiny little devices, you would send the programs, the agents, to the network servers where they could do the heavy lifting, and then just send the results back to the user's PDA.
So it's kind of like how we use web apps today.
Yeah. It's like, you access a web app on your phone, but all the real work is happening on a server somewhere else. So how did they actually make this happen? What was the technology behind Telescript?
Yeah. What was it?
So Telescript was actually a complete programming language
Oh, wow.
and platform. It wasn't just a protocol.
Okay.
It had its own syntax.
So developers had to learn a whole new language.
Yeah. It was called High Telescript, and that would be compiled into this bytecode called Low Telescript. And that bytecode would then be executed by a Telescript engine.
The Telescript engine. Okay.
Which is basically a virtual machine, kind of like Java's virtual machine.
Right. So it provided this environment where the Telescript code could run.
Exactly. And it would run on both the mobile devices and the network servers.
Okay. So how is that different from Java?
So Java, you typically download the code to your computer.
Right.
And run it locally.
Right.
Telescript did the opposite. You would upload the code to the network server for remote execution.
So it was a reverse model.
Yeah.
Designed specifically for this client-server interaction.
Yeah. And they had this idea that the server would always be more powerful.
Right.
So that made a lot of sense at the time.
Yeah, especially with those early mobile devices. I mean, they were severely limited in terms of processing power.
Yeah. So Telescript tried to solve that by moving the computation to the network.
So we've talked about the language. What about other features? Was it pretty advanced for its time?
Oh, yeah. It could do multitasking.
Okay.
So you could have multiple agents running at the same time using preemptive multitasking.
Okay.
And it was heavily object-oriented.
So like modern programming language.
Yeah. Everything was an object. Even basic data types like Booleans, like Smalltalk, if you're familiar with that.
I've heard of it, yeah.
And the whole system was built around two main classes, agent and place. And both of those were actually subclasses of this more fundamental process class.
So very object-oriented, very modular.
Yeah.
That's interesting because object-oriented programming was still relatively new back then. It wasn't as widely used as it is today.
Right, but they were really forward-thinking in that sense.
Right.
They saw the benefits of that kind of modularity.
Okay. So you keep mentioning these agents. What exactly was an agent in the Telescript world? Like, what was the concept?
So an agent was basically a piece of mobile code
Okay.
that could travel across the network
Mhm.
and do stuff. It wasn't just transmitting data.
Mm-hmm.
It was sending the actual logic to be executed somewhere else.
That's a really interesting concept. Like the program itself is moving around.
Exactly. They had this principle: move programs, agents, with necessary processing across the network and execute them at locations, places, with data and services.
Okay. So the agent goes to where the data is.
Right. It's not about bringing the data to the program. It's the other way around.
And what were these places?
So a place was basically a network service node
Okay.
that could host these executing agents, and even the user's own terminal was considered a limited type of place.
So like a simplified place?
Yeah. And an agent could use this go command to travel from one place to another.
So it's literally moving around the network.
Yeah. And they even envisioned these multi-hop journeys where an agent could visit multiple places in sequence. Like imagine a shopping agent. You could go to one store, check the prices,
Right.
go to another store, compare prices, and so on.
Okay. So it's hopping around the network doing its thing.
Exactly. And once it's done, it can either return to the user's device
Mm-hmm.
with the results, or it can even spawn another agent, a messenger agent,
Okay.
whose sole purpose is to deliver the results back to the user.
That's really clever. So it doesn't have to make the round trip itself.
Right. So this whole idea of dynamic network traversal by these agents, that was the defining feature of Telescript.
And it was pretty revolutionary for its time, especially considering how slow and unreliable networks were back then.
Oh, yeah. It was a huge challenge.
Yeah.
But they were trying to solve it by, moving the computation to the data instead of trying to move all the data around.
Right. Makes sense.
Mhm.
Now, could these agents actually talk to each other? Like directly?
Yeah. So if two agents were at the same place, they could use a command called meet to call each other's procedures.
Okay.
So they could interact directly.
So it's like peer-to-peer communication within that place.
Yeah. But it required this kind of negotiation process called a petition.
A petition. Interesting.
Yeah. So basically both agents had to agree to meet, and then they had to have this time-based rendezvous where they would both be present
Okay.
at the same time to establish the connection.
It's like setting up a meeting in real life.
Exactly. But for AI agents, and for agents that were in different places on the network,
Mm-hmm.
they had this connection mechanism,
Okay.
which would establish a communication channel between them so they could exchange messages and collaborate on tasks, even though they were physically separated.
That's pretty cool. So they had these different ways for agents to communicate, whether they were in the same place or different places.
Right. And it was all part of this bigger vision of building this distributed system.
This Telescript cloud that we mentioned earlier, what was that all about?
So the idea was to connect multiple servers together into this cloud, and that cloud would host all these places and agents, and it would provide the infrastructure for their electronic marketplace.
So this is where the term cloud potentially came from.
Yeah. Believe it or not, they were using the term cloud back in the early 90s to describe this network of servers.
That's amazing. So they were really pioneers in many ways.
Yeah, they were. And they had big plans. They were talking to AT&T, NTT in Japan,
Wow.
France Telecom. They wanted to deploy Telescript-based services globally.
So they were really aiming for a global electronic marketplace.
Yeah, they were. Now, of course, one of the big concerns with all this is security.
Right. I mean, if you've got these agents running around on the network doing all these things, how do you make sure that nothing bad happens?
Yeah, security was a huge priority for them, and they came up with some pretty innovative solutions for the time.
Okay.
They had these things called permits,
Permits. Okay.
and these permits were assigned to both agents and places.
Okay.
And they specified all sorts of limits, like how long an agent could run, how much memory it could use, which commands it was allowed to execute.
Oh, wow. So it's like a very fine-grained control over what these agents could do.
Yeah. They even had these things called teleclicks, which were like units of resource consumption.
Teleclicks. That's a great name.
Yeah. And the permits could be renegotiated and updated as an agent moved between different regions of the network.
Regions. Okay.
Yeah. So they had this concept of dividing the network into regions, and each region could have its own local permits.
Oh, okay. So you could have